Okay, welcome all. This is the first installment of the Risk and Resilience Tech Hub Sustainable and Resilient Infrastructure Seminar Series. That is a mouthful. So the Risk and Resilience Tech Hub is EDA-funded tech hub that aims to lead global commercialization of resilience technology. And Miami-Dade County is leading this project. This is one of 31. The numbers vary just a little bit, but federally designated tech hubs. It's a fantastic example of a public-private partnership working across our four-county region. And the major objective here is for workforce development, for commercializing a lot of the solutions to increase their TRL, to develop jobs, to support startups, and ultimately to help national security and for us to have a resilient economy and infrastructure. This project has been supported to the tune of about $20 million for the next 5 years. The component projects that have been funded are next generation concrete, workforce governance. Some of the details are presented here. These are led by FIU, Miami Tech Works, and the county. This is a very nice schematic that kind of shows big picture, what we're doing, what we're interested in doing. It also shows the addressable market sizes for all of these initiatives. I don't want to spend too much time on this, but a lot of you on the call are involved with these efforts, and we will be continue to be involved with these efforts. Now, this seminar series, of which this is number one, the idea is that we bring people together. We have folks from startups or otherwise talking about their high TRL technologies. We want to educate, we want to disseminate information, ultimately to accelerate TRL, to accelerate adoption, and also to understand what's happening with some of these technologies. As an example, we want to advance startups. That's a major objective. So a lot of the talks will be from startups. And we aim that here we will get not only people from academia and industry, but also strong support from government and from VCs. So here's the flyer. The first one is going to be given by Mr. Adam Friedman, who's co-founder and chief executive at 1Print. He's an expert in 3D concrete printing, and 1Print uses advanced 3D concrete printing. And Adam is going to talk much more about it in much more detail and with more clarity than me. But he's going to present some really nice stuff on how they can make novel infrastructure, novel housing using 3D printing advancements. The seminar series, this is our schedule. So we have 4 more coming up. 3 of them are set up. 1 is to be finalized soon. And if you want to present, if you want to talk about what your company is doing, especially if you're a startup, send me an email. We'll make it happen. We'll get going now. Adam is going to present, but just very quickly, why don't you write a few lines of introduction about yourself in the chat so that everyone can get to know each other better. So Adam, this is all yours. We'll do roughly 45 minutes and then Q&A. Thank you.
Great. Thank you, Prannoy. Thank you, everyone, for being here. I will share my screen here and jump right into it. So again, good morning, everyone. My name is Adam Friedman. I'm co-founder of 1Print. I founded it with my co-founder, Frederick Wanius, who many of you might know. We will get into a few things into this presentation. First and foremost, an introduction of 1Print. Who are we, right? We do a lot of things under the shadows, but we do a lot of things, have a lot of great partnerships with many people on this call and many people within the Risk and Resilience Tech Hub, whether it's universities, engineering firms, private entities, and commercial. My team here consists of many people. I have a great team here at 1Print. Again, myself, Adam Friedman, Frederick Wanius. We have Ian Arthur, who's the head of our housing division and does a lot of our operations. Fred Meinke, who is head of our coastal division, which you'll learn more about, and helps out with some logistics as well. Our investor from TEI, his name is Francis Greenberger. He's a great man, real estate Mongol from New York City, who's a very good supporter of our team. We work closely with Titan, with Eric Kohler, Guillermo, Sudok, and our partners at University of Miami, Dr. Landoff, Dr. Pernoy, and many others at University of Miami, whether it's Esper, Brian House, Andrew Baker, many people, and we'll get into those thank yous a little bit later. So again, some logos that who we work with closely, whether it's on grants or we're doing research and development or testing, or we sell 3D printers as well to some of these entities. We have big thank yous to all our collaborators, and again, University of Miami, FIU, FAU. We talk constantly with people over there. Risk and Resilience Tech Hub, huge thank you for putting this all together, doing a great job, and there's a bright future for South Florida. So who is 1Print and what is our journey? Frederick and I have been working together for about 5 years. We started off in 3D printing construction. So that's vertical buildings, houses, and we started back in 2020, where we had some of the first 3D printed structures in the world down here in South Florida. Titan America and Guillermo was a huge supporter of us and helped us in the very beginning. Through that time, we had many visitors, right? It's a novel technology. A lot of people want to know about it. We had congressmen and Department of Defense and lots of people visiting. Even Anya from Kind Designs came by and learned a lot, took a lot of notes. And there was a progression into some housing projects, and can't show all the pictures here, but through our team, there's probably I would say 15 to 16 structures under our belt of vertical builds, which are huge endeavors, especially with new technologies. So Frederick and I are part of the first permitted house in Florida, one of the first permitted houses in the world. And we started our collaboration with the Department of Defense, the Tyndall Air Force Base, AFCAC Division. 2022, Guillermo for 1Print introduces us to the University of Miami team. And this is where the first ever Sea Hive, which you'll learn about in a little bit, was 3D printed on a whim. And that started an incredible partnership and kind of a pivot into coastal infrastructure, which we love, and was a very, very good move for us. Then we were into some projects. We won a grant through the Army Corps of Engineers, which was through Army, as a direct to phase 2. Our co-collaborators on this grant were Titan, University of Miami, and Carbon Limit. These were to 3D print and validate the material for 3D printing for Sea Hives, which had a close national security use there. We also completed a first major project in Okaloosa County. Moving into 2024, this was a big validation year. We believe in validation before going to market. We don't want to put out any false claims. We want to make sure that we are getting the stamps needed. And with our partners through the grant and other projects with ACOM and some come at Cedarburg and some other engineering firms, we're receiving those stamps. And there was a project in that time, the DARPA Refence project, which is an amazing project that we worked on with University of Miami and ACOM and many collaborators. That you can see that structure there in the back. That was a strong step towards really making sure that our engineering was sound and ready for market. Now, 2025, we are putting down some of our pilots from the grant, which we will get into here in a little bit. And we have expanded back into our housing portfolio. So we are now opening back up into resilient housing. In my opinion, concrete houses are needed here in South Florida that are hurricane resistant. And we are starting to build our portfolio back up of not only can we 3D print your structure or building, but we can also protect it from the waves as much as we can. So going into our divisions, we have our infrastructure division, which works primarily with coastal solutions, which are the Sea Hive solution and some other things that I'll show a little bit later. Our real estate division, which is under our construction, and equipment and materials. Not many people know this, but we do resell about 5 different OEM 3D printers. We are very familiar with the 3D printers of the world. This one right here is a UTU 3D printer from the Ukraine, which is being delivered to FIU. And I know Emily is crossing her fingers here within the next month or so. So this is ready for shipment. This is the final test. So what is concrete 3D printing? You've heard me say this a lot. 3DCP is the abbreviation in the industry, and it is an very advanced additive manufacturing method, which extrudes concrete or mortar material. And this is great for speed and design freedom and lots of different materials that can be tested in there. So many of the use cases are the same as a desktop 3D printer, but on a much larger, grander scale that are for production. So I won't read all through these. I know we have some short time here, but again, you can highly customize units that are 3D printed and be precise to what the needs are of the landscape or the customer. Structural, you can ensure that these structures are able to withstand certain forces, partly because of design freedom, but partly because of the way in which you can reinforce. We talk about speed, and with speed comes lower costs. We talk about sustainable design. A big initiative here at 1Print is working with nature, which we will talk about, not against nature. So everything we do on the coastal, we want to ensure that nature is growing with us, whether it's mangroves, oysters, corals, grasses. And these there is studies and data, partially through the Refence project, that these do attenuate waves even further. And portable and scalable. These are machines that can be brought right to site. This cuts down on logistics and allows for us to work in remote regions. This is something we're working on the Department of Defense with, to ensure that they have the right machine and the right tools to be able to do this in very remote regions. Right here, what you're seeing is a year in review of 2024. So we've worked on the grant. We had some major deployments and projects that went down, lots of product development with collaborators in the industry. We work with a lot of our, whether they're competitors, we're still working with them to improve what is needed out there. We worked on the DARPA Refence project, which was a lot of time and energy, but was a great project to work for. We launched a collaboration with Carbon Limit for their CaptureCrete 3D printed concrete application. So this was part of our grant where we validated that. We worked with the EDA, which was the Risk and Resilience Tech Hub awardee, for making sure that we're putting this risk and resilience project into place. I'm a steering committee member. I told you about the UTU machine to FIU. We heavily worked with engineering firms. We were testing different machines. This machine right here is a big boom machine here on the left. This is a Putzmeister machine. This is great for in situ or disaster relief projects. That's at our plant at Titan. And then we were the first company in the United States to print right from a ready-mix truck, which is a big deal logistically. And this allows us to drop our prices even more, so which is good for the customer and good for the project. But the ready-mix step was a huge R&D, and we again, thank you for everyone on there. We worked with a couple partners on a DARPA Trenton application, including University of Miami, GE, Vernova, U.S. Army Corps of Engineers, Titan, FIU was involved, U.S. Army Corps of Engineers, Air Force Civil Engineering Center to apply for the Trent program, and that's for underwater 3D printing, which we will show later. And then also we had an application to the U.S. Department of Energy for energy created by waves combined with our Sea Hive units, and that is to create renewable energy for, again, very remote regions for the Department of Defense. So our coastal and land kind of diving back into our divisions, like we said, we say coastal and land because right now we work on coastal, but we are opening up to some land solutions with partnerships with FIU for bridge components and tunnel components and stormwater. But right now, our validated products lie in the coastal. So we look to protect anywhere from the DoD to the DOT, DOE, and civil markets and commercial markets, also communities and warfighters. We have a couple different products. We support the C-Hive product, which is an exclusive license to 3D print the C-Hive product that came out of University of Miami, and that's a worldwide right. We also have a product called Reef Wall, which is more of a seawall, and a couple other products that I can show a little bit later. R&D funding, we are always looking for research and development. We love research and development and collaboration, and we have a big focus on nature-based solutions or dual-use systems for military and civilian use. When we get into our construction division, this is a project that is supported by the Risk and Resilience Tech Hub. There's a project we are working on in North Lauderdale. It'll be 3 of these units down below, 2-story. And this will be for workforce housing, and it's a very exciting project. We are also working with the DoD to help them with resilient structures for on their bases and such. So again, this is a big comparison we get asked. The comparison is, hey, we have a CMU block, which is your conventional block. We can build this building in this much time and this much price. And with our advancements here and our expertise here on my team, Ian Arthur, we have been able to compare with CMU block in price and a little bit less in time. But the big kicker is that CMU can be anywhere from 30 to 40 workers to put that in place, where it takes us 3 to 4 workers in a robot to put that in place. So there's a big problem right now with labor shortage, as we all know. The younger generation does not want to pick up giant blocks and put them down, but they do want to operate a 3D printer and extrude concrete from an air-conditioned hut there. Again, these are things that we are always looking for funding and R&D and collaboration on, something that we hope to further here now that we have the right personnel and the right people on our team. Currently, the Florida project I told you about, we are launching very soon, and then we have another project, a commercial project up in New York. And again, the Florida project is a component project for the Risk and Resilience Tech Hub. Quick case studies. When I talk about speed and I talk about customization of 3D printing, this is a wave attenuation wall that, if you see in the top left, May 22nd of last year, we received a phone call that they needed a certain kind of wall with a certain kind of shape. It's a job that we've done before, but we were already in production for another project. And when they asked how long it would take to get it to them, we said, a couple weeks. Give us a couple weeks, please. And they said, can you get it to us in a couple days? And we said, sure. So May 23rd, we went back into redesign and standard operating procedures. May 29th, a week later, we started printing. Fast forward to June 6th, so roughly 2 weeks later, it was being installed. So this is the speed in which we're able to design, produce, and deploy. And this is where a lot of the cost savings come in, is, one day on a barge is a lot less than 2 weeks on a barge. So these are the things that we think of. We think of the end in mind and deployment when we are printing these items. So why are we in coastal, right? Obviously, it was a big pivot or an expansion from our construction division, and there had to be a compelling problem and a great product and team for us to expand out. And that's what we found at University of Miami and our other collaborators. So I'm sure a lot of you are aware, maybe you're not, but the coasts are at risk. There's a lot of aging infrastructure. Storms are battering the coast. Vegetation, whether it's mangroves and corals, are dying. And this is where the C-Hive solution comes in. So we are a foundation for habitat to grow, which again has data that they attenuate the waves. Of course, the sea hive structures attenuate also, but why not put two lines of defense when you can and make sure that the design and engineering allows for that growth. Now, we get this question on the coastal side, kind of the same question we get on the construction side. So on construction, it's CMU block, lots of time and labor. On the coastal side, it's riprap, right? Conventional stones that need to be put down one by one in a very specific slope and manner with lots of engineering. So it is killing habitat and environment. It is not great for the environment. We have I have a case study and a couple slides here that shows that. And it's high cost, it's high time, and erosion is worsening. There is a lot of maintenance. The sea hive does work on reversing the erosion. It's custom designed. So if you come to us and you say that you have this much depth of water and you need to attenuate this much waves, and this is your goal on the backside of it, we work with our teams at University of Miami and engineering firms to get that design ready and into production as soon as possible. The sea hive system, because of the porous holes there, brings the water in, confuses the water, and then calms the water on when it exits the backside, sort of like a filter, or as you can think of as a breakwater. Again, we try to harbor the habitat. So getting into other things, just to speed through this, there's of course the wave energy diffusion, sand accretion, ecological restoration. We're improving water quality. We are working on bringing in the hybrid reefs back. So we work with Dr. Andrew Baker and the team at University of Miami for bringing with his corals in his lab, planting corals down on submerged breakwaters that are bringing the corals back, that are heat resistant, that to allow for the rising water temperatures. So of course, economic benefits. We really try to dig into our customers' needs, whether it's downtime of their port, it's reducing dredging in their shipping lanes, or refurbishing their beaches, or of course for national security, ensuring that our ports and bases are protected. With this, we were featured in the Army Corps of Engineers, Engineering with Nature. This was written with Dr. Landoff, Dr. Pernoy, and our team, and thank you very much for that. This was a great collaboration. Going into our grant. So we have a direct to phase 2 Army grant that is managed by the Army Corps of Engineers in Vicksburg, with collaborations with some other teams, like I said, Titan, University of Miami, Carbon Limit. And just to kind of speed through this was about material, right? How to ensure the material that leads to the structural design, that leads to some pilot projects, and then down to the deployment. These were our original pilots here. So you can see that in Pompano Beach, this was a seawall mangrove planter with a sea hive in front with some redirects to redirect the waves back. Remember, design freedom gives us a lot of creativity in this. So this was for mangroves. In Jupiter, Florida, we'll be going down in a couple of weeks here. This was a mangrove planter in the back as well, with some cleats to keep them in the sediment, anti-scouring, lots and lots of features that we're able to do with our partners in the room, right in the CAD system. And then this one was either in Broward County or Miami County. This was to plant corals. So mangroves, oysters, and mangroves, and corals. So some of our findings from the grant, this is a big finding here at 1Print. Traditionally, sea hives were designed to be individual hexagonal units, as you can kind of see here. And you can see that the time in which this would take for us to print and the material is far greater than what it would take if we clustered them. So about half the time and a lot less of the material. So the clustering allows us to get more units out into the water faster with less material. This also helps with deployment. We didn't put our deployment graph here, but if you can imagine lowering these down one by one can take a lot more time than just lowering this unit down as a cluster. So the testing for this grant, there was structural, material, also then the wave tank, and this is a couple different designs. I know it might be hard to see this graph, but I can summarize it. Many different geometries and rebar placement and grouting systems to see what is the optimal design for when we go to produce these. So when you say what do you mean the design? If you can see here, it might be hard. This is a circle within a hexagon, where this one is a hexagon within a hexagon, and there's all sorts of different variants here. And this is something Dr. Landoff put together and executed. A couple different graphs talking about recycled material. We have a big initiative. When I say we, us at 1Print and Titan has a big initiative to recycle materials and to see how we can reuse those. We are at the Titan plant, and their crushing facility is about 20 yards away from our facility. So it's a very interesting life cycle. Many results from Dr. Pernoy. QA/QC, we're very strict on QA/QC, and we're getting better and better at this. We like showing our flaws because we're not going to claim that we're perfect, but we are getting better and better. That's the most important thing. And we've done a great job to fix these issues that we found early and are finding ways to operate more efficiently and more securely. Now, one of the hardest parts of the job is how do we lift a 40,000 pound piece of 3D printed concrete? And this is something, and safely, right? So safety first. And this is something that we learned a lot during the grant and learning a lot during our projects, our commercial projects and DoD projects, that lifting and deployment needs to be taken into consideration as part of the design process in the beginning, right? So we need to know where we're lifting. We need to know if we need extra reinforcement, and how are we doing our operations? You know, we don't want to think of something when it's too late. So this is a very important step here. Some pictures of our pilots lined up, ready to go. There's a lot more units throughout the yard. There's a couple of drone shots that we have, and these are all ready to be shipped. And what we like is our efficiencies with our trucking systems, that we bring in multiple trucks, we load, they go to the barge puts them onto the barge, and it's an endless, continuous cycle. So to make sure, again, efficiencies. So the lessons we learned, I can go on and on. I can have another hour seminar about lessons that we learned. Just lessons I learned last week could take an hour. We are learning thousands of things a week, I would say. But the big things, to put it down to a boil, is production efficiencies to ensure that we have the right quality and the right timing, and our staff is fully aware of what is being produced and why it's being produced. All sorts of different curing and techniques that might be learned along the way. Permitting is something that is a huge lesson for us. You know, it's different than house permitting. This is something I'll get into a little bit later. And logistics, the importance of logistics. It's a big step when you're transporting things from a warehouse to the dock. And of course, we do an evaluation of, does it make more sense to bring one of our machines to the dock and do it right there? So the permitting challenges, MIT has been working with the Risk and Resilience Tech Hub on an evaluation of what are some of the permitting issues. And I just think it's so interesting, and I think they're doing an amazing job. I actually, I give them credit here. I grabbed this from one of their presentations, but there are a lot of issues that you face. It can be based on the person who's managing the permit, or the department who's overseeing it. And also so when you get into habitat, there's a lot of factors that you need to think of when you're interacting with the habitat. So lots of things on permitting, and that's more information to come on that. So R&D, what are we doing kind of in the shadows here? Couple things, we can't put everything here, but we can highlight a few. We are working on perfecting underwater 3D printing. using dredge sediment. We worked with Army Corps of Engineers, ERDIC, on this and some of our partners. So we are able to 3D print underwater to a certain degree. Well, obviously, it's not ready for use, but a lot of science and a lot of engineering comes to that. Like we said, the ready mix concrete, this is a huge step for the entire industry for us to be able to go right from the truck to our printer. Another project we're working on is for wave energy. So we are able to, we teamed up with a team in Italy that has a high TRL level that as the waves come in, it turns a turbine, will create renewable energy. And we can combine this, in this bottom right-hand picture, this might be some riprap technology that someone used at one time, but these ideally would be sea hives that encase it and on the backside. So lots of projects going on. Something that one of our partners has been working on since 2016, Dr. Keith, are these reef wall panels. And these are the data and the validation that he has is incredible, and we're very thankful for his partnership. So these reef wall panels, we have found a way to mass produce these and get these out at a great rate. And also we can talk with the local environment to see what is needed in case we need to iterate. We took it a step further and we have made it into a reef wall. And this reef wall is in collaboration with a couple partners. It's not just a slab of concrete. There is a lot of technology in this that allows it to be deployed very quickly and transported very quickly. And obviously the habitat promotion there is an important key here, as well as wave attenuation. Some other projects we are working on are ready for market, as well as the reef walls, are the riprap replacement. So there's we have modular riprap that's able to be placed quickly, it's able to be moved, and it promotes lots of habitat and can be stacked and logistically favored when putting this down. These pictures are very hard. I tried to put them through an AI enhancement, but it started adding fish and other things, and I wanted to make this very honest. So on your left-hand side, this is conventional riprap. There's not a fish in sight, and this is 10 feet away. This is our riprap replacement with lots of fish. I know it's hard to see. There's even more down here who are swimming in and out of the hole. So very successful. We're hoping that Broward County approves this very soon, and we have these in the water other than just pilots. So what are 1Print's asks? So we don't ask for much, even though maybe some of our partners will disagree, but we are always looking for research partners, projects that we can work on with people, whether we're the prime or we're a sub. And these research projects can be grants too, just project grants that, let's build it and put it down, or full research as part of it. We welcome both. When it comes to scaling, we have directed a pre-seed investment round. It's a kind of an exclusive first right of refusal for some very close partners currently, and then we are going into a seed investment round Q3 2026, which people say we're late, but I think we're lucky that we haven't needed money, but now it's time to scale with our validations. As far as hires, we are looking for extremely professional people on the marketing side and sales support, operators of our machines and our pumps and our material, and bringing in some engineering here for coastal, structural, and material engineering. We look for a professional stamp. So always looking for projects, whether that's on the construction side. If you have a housing development, we like to be a little bit more than 5 to 15 to 50. That's kind of our sweet spot tiers. And then as far as coastal projects go, civil, commercial, private, DoD, we're always open to talk and collaborate. And also DoD, we have a few DoD, and we have a lot of people helping us with the DoD, and thank you for that, for those projects. So I think I'm right on time. I know I sped through a few things. I can definitely take some questions. Again, feel free to reach out to us at our emails here, adam@oneprint.one, or my business partner, Frederick, at oneprint.one. Thank you.